Okay, now in this section of chapter 23, still in the non-helminths, but just kind of breaking that up a little bit. So continuing on with these that are caused by non-helminth microbes. All right, so still focusing on diarrhea. So here we have acute diarrhea. The main section here is looking at food poisoning. So just some of the hallmarks and signs of food poisoning. So nausea and vomiting are accompanied with diarrhea. So again, we just covered those with or without. So these are focusing on diarrhea with vomiting, accompanied or often companions that shared a meal have similar symptoms or similar fate. And these are going to be caused by the gut, where there is an exotoxin that has been released that has led to the vomiting and nausea. Occasionally, this can come from non-microbial sources, so just fish, shellfish, and mushrooms can also induce food poisoning that necessarily isn't caused by the microbes themselves. So this is referred to as intoxication rather than infection. All right, so our first one here looking at Staph aureus. So of course we talked about staph before whenever we covered the skin infections. But this one is going to be found that's producing this exotoxin, typically found custard sauces, creamed pastries, processed meat, chicken salad, and ham. It's just like we talked about before with the skin, so it tolerates that high salt tolerance. The enterotoxin that it produces is heat stable, so cooking the food doesn't destroy that enterotoxin that was produced. It causes the symptoms of the nausea, vomiting, and diarrhea. Typically, onsets within 1 to 6 hours, and then pretty quick recovery, essentially within a day. So this is self-limiting, so antibiotics are not needed for this. Then Bacillus cereus exotoxin that's produced. So Bacillus is one of our spore formers, so it's a sporulating gram-positive bacteria that lives in the soil. So it is emetic, which just means it induces vomiting. So this form is typically tied to fried rice that's been cooked and kept warm for a long period of time. So thinking about like a Chinese buffet, not that all of those are bad, but just a place that this is commonly seen. The diarrheal form, though, is typically associated with cooked meats and vegetables held at a warm temperature. Again, the key here is those long periods of time. And this leads to profuse watery diarrhea, at least for a 24-hour period. The Clostridium perfringens, this exotoxin, we talked about this before whenever we talked about gas gangrene, so it's the same microbe, but this not focusing here on the gas gangrene, but on the vomiting and diarrhea. This can come from contaminated meats, fish, and beans that weren't cooked properly. Again, it's a spore former, so it's not killing all of those spores. Again, once it's inside the GI, it can then germinate. So then those cells enter the small intestine and produce that exotoxin. Like with the others, we have the abdominal pain, diarrhea, and nausea lasting about 8 to 16 hours. And then this also causes enterocolitis that looks similar to Clostridium difficile. And so our little summary table, again, all of these are producing are caused by the production of those exotoxins. 2 of them, the Clostridium and the Bacillus, are producing the spores, whereas the Staph aureus does not. Again, they're all food poisoning as a vehicle here, and all of them share the virulence factor of the exotoxin. Again, treatment isn't needed other than supportive for all of them. And again, so just kind of the foods that they're most commonly found in is what can be a little different. All right, so now moving into the chronic diarrhea. So instead of just short-term diarrhea, so this is defined as diarrhea lasting for longer than 14 days, so 2 weeks. Now we move into the chronic stage. It can have an infectious or non-infectious cause. So for example, irritable bowel syndrome or ulcerative colitis are non-infectious form, so you didn't actually get them from somebody. It's still caused by a microbe. It's still infectious. It's just not, can't be like passed on. So the microbes here, again, cause chronic diarrhea in otherwise healthy individuals. So looking at these, they're the E. coli, so enteroaggregative E. coli or EAEC. This is associated with the chronic disease, especially in children. It can adhere to human cells and it aggregates rather than in single cells, hence the name enteroaggregative. So again, we kind of see these cells here that are in aggregates or kind of clumps. That's where these are going to be found. And then it stimulates large amounts of mucus in the gut and transmitted from food or water. The Cyclospora cyantensis. This is a protozoan. So again, most of our microbes here in this chapter are bacteria, but this is another protozoan that's starting to emerge. So numerous outbreaks have been reported. This is due to fecal-oral transmission in fresh produce and also in water. The protozoans form those oocysts. So these are the ones shown down here. So kind of that dormant state, not as resilient as our endospores, but definitely can withstand some different treatments and as far as drugs or disinfectants. So that oocyte is made. Some of the symptoms from this, again, watery diarrhea, stomach cramps, bloating, fever, and muscle ache. Giardia duodenalis. Giardia has a really cool shape. It actually looks like a kite, so it's pretty easy to identify under the microscope. A couple different names for it. This is the most up-to-date version, though, but just a few other names in case you've come across them. Again, another protozoan here that has a flagella, so it's mobile. Again, identified by that unique kind of symmetrical heart shape. Again, I think it looks more like a kite. With the organelles positioned so that it resembles the face or 4 pairs of flagella. So again, pretty easy to recognize under a microscope. So some of the signs and symptoms, so diarrhea for long durations, abdominal pain, flatulence, greasy, and malodorous stools. And this one is particularly an issue with contaminated water. So drinking from streams for hikers or pets, this can be an issue. And another non-bacterial one here, so the entamoeba, so amoeba shown here as eukaryotic, so entamoeba histolytica, because it has a simple life cycle, alternates between the trophozoite and the cyst, so it's one of the protozoas. It secretes enzymes and dissolves tissues. Amoebiasis exits the intestinal and intraintestinal forms. And then humans are the primary host for this, and infections through the food and water that have those cysts. So again, dormant kind of state, not as resilient as the endospores, but again, you can see the cyst, kind of mature cyst up here that develops, and then it progresses through to the trophozoite, which is actually the feeding stage of the protist. All right, so some of the signs and symptoms, so looking first at the intestinal amoebiasis. This is in the lower GI, so the cecum, appendix, colon, and rectum can penetrate into those deeper layers. Causes dysentery, which is that bloody mucus-filled stool. The extraintestinal, so outside of the intestines, amoebiasis, it can invade the viscera of the peritoneal cavity and then invading the liver. That can then cause a lot of damage there. Right, so our summary table, so the EAEC, so that E. coli, again, food, but also fecal-oral, like we see here with the Cyclosporia. Again, as far as treatment for these, mainly going to be supportive rehydration that's there to help with these. But again, all of these are causing that chronic diarrhea. Then the Giardia, and then the entamoeba, again, both of these are protists, both by vehicle and fecal-oral transmission. Again, the Giardia can attach to the mucosa. The entamoeba has those lytic enzymes. It can be invasive to cause its disease. Typically no fever with the Giardia, but it is seen with the entamoeba. And some of the distinctive features here, again, this is the Giardia, the campers and backpackers, as well as pets, are more likely because, again, drinking that contaminated water from streams while hiking. Now moving into some of the other GI diseases, so hepatitis here, which is an inflammatory disease of the liver. It causes necrosis or the death of the liver cells called hepatocytes. It's a response by the mononuclear white blood cells, so again, our immune system swells and disrupts the liver architecture, so again, a lot of damage from trying to defend against the bacteria more than the bacteria itself necessarily, or from the microbe. It does interfere with the excretion of bile pigments, causes bilirubin to accumulate, and that can lead to jaundice. Right, this is caused by viruses, so hepatitis A is non-enveloped single-stranded RNA. Some of the signs and symptoms, so kind of so subclinical or vague, so not a lot of symptoms, to flu-like symptoms. Jaundice only in about 10% of the case. As far as transmission, this is by the fecal-oral route that it is. So again, lack of hygiene and public health measures. Immunization is available for Hep A. Hep B is enveloped. It is a DNA virus. Some of the signs and symptoms, fever, chills, malaise or tiredness, anorexia, abdominal discomfort, diarrhea, nausea. Rashes and arthritis can even occur. And it can cause cancer, so hepatocellular carcinoma. It is transmitted in minute amounts of blood, so this is particularly problematic in the healthcare where exposures to blood can occur in that setting, of course. So there is an effective vaccine and is required and important for healthcare workers and students to receive those, as well as those who are immunodeficient and cancer patients to prevent an infection. This is just looking again at the Hep B virion. So again, it is enveloped, so it has that membrane around it, then the capsid, and then the DNA inside. Then Hep C is kind of the silent epidemic. About 3.5 million Americans are infected. We don't typically hear a lot about these infections, but these numbers are pretty staggering. Signs and symptoms similar to the Hep B, but again, 75 to 85% remain infected indefinitely. So this is a chronic, it is a chronic infection that does not go away. So transmission by blood transfusions and needle sharing. No vaccine, though, is available for the Hep C, but there are a couple drug regimens that are available to try to target the virus. All right, so our hepatitis table here, so we have Hep A, B, and C. So of course, all viruses, there is a vaccine that's available for both Hep A and Hep B, but there is no vaccine or prevention for Hep C, which is that chronic form that doesn't go away. It has a much longer incubation time than the others, but again, all infecting the liver.